Alright, so I didn't talk about IP addressing, so let me deal with IP addressing. It was part of the outline, so let me deal with IP addressing. So IP addressing is internet protocol address. Okay, let's take it like your house address. Okay, so every house has an address of which let's say you are delivering, you requested for a delivery man is actually delivering a package to your house. There should be an address of which that delivery man will deliver the item or the parcel to your doorsteps. All right, so have two IP address technologies. We have the IPv4, or IP Internet Protocol version 4 addressing technology, and then the Internet Protocol version 6 addressing technology. But we are going to focus much on the IPv4 right now. Okay. So the Internet Protocol version 4 is one of the protocol that is widely used in terms of the networking protocols. Okay. It actually provides us with a primary addressing mechanism. Okay, so that's under what is called as the internetworks or the internet. Okay, so which is actually used for identifying the location of devices on the network. So I talked to you about your house address, which we actually use to identify the location of your house. And the same thing applies when it comes to computers as well, when we join them or when they are on the network. So this IP version 4 address or the IP address is naturally using to identify computers that are joined on a network. Alright, so let's look at certain terminology, certain keywords or information that we actually need to know about IP version 4 addressing technology. So the IPv4 is a 32-bit. When we're talking about bits, we're talking about these binary numbers. Okay, 1 and 0. This is what computers actually knows in terms of languages or how it speaks. It speaks in binaries. So the 32-bit IP addresses is organized in 4 groups of 8 bits. So we know that 8 bits makes us what is called a byte. All right, 8 bits is equal to 1 byte, so 8 binary bits. So I'm talking about different ones and zeros, 1 0 1 0 1 0. So 1 2 3 4 5, let's say 6 7 8. So this actually made up to 1 byte. Okay. So you say that it's organized in 8 bits. So if we assume of dividing this bit, so it says 32 bits. So if we're dividing this 32 by this number, so if we are dividing the 32 by 8, we are going to get 4. So it says it's the IP address is grouped into 4 different groups. So okay, so we are going to have 4 different groups. Let's say it's going to be like A. Let's say going to be another group B, let's say another group C, and then let's say another group D. So these are the 4 groups that we have, and each decimal, so each group is a decimal value. So it could be like 100, could be like 200, could be like 500, 100. They are all decimal values. Okay, so each decimal is separated by a period. Then it means that each group here is being separated by a period. All right, okay, so we have a period here in between these 2 decimal values, here as well and here as well. So this is an example of illustration of how IPv4 looks like. We have an address of 192.168.1.20. The same thing that we are trying to understand at this point. So each decimal, like as I said, each decimal has been separated by a period. So these are all decimal values. All right, so we have 4 different groups, and each group has what is called 8 bits, 8 binary numbers. So we know that computers understand binaries. So we raise 2 to the power of 8 is going to give us 256. Okay, so what it means that each bit contain a decimal values can range from 0 up to 255. That is what it actually means. So each group here, so we have 4 groups, right? So each group can range from 0 up to 255. So if you raise 2 to the power 8, this is what we are going to get: 0 up to 255. Alright, so each group is going to contain that. So let's move to the next one. So each of the 4 groups, these 4 groups that we are talking about, like this, let me wipe off the screen a bit. So these 4 groups that we actually have here is called an octet. So each of this is called an octet. So octet 1, octet 2, octet 3, and octet 4. Right, bear in mind that's the name, octet. The largest possible 8-bit in terms of this. So I said that each group or each octet contain 8 different binary numbers. It could be 1 1, it could be 0 0, or it could be any of them. Okay, so the largest possible 8 binary bit that we can have in each octet is going to be ones. It means that all these values have been turned on. That's what it means. So 1 2 3 4 5 6 7 8. So this is the largest binary bit that we can have. So if you turn all this one on, it's going to be like 255. So each of the 4 octets can be any number. As I said earlier, each of these 4 octets can be range from any number from 0 up to 255. Right? So here going to 0 up to 255, here can range from 0 to 255, here can range from 0 to 255, here can range from 0 to 255. Right? So we have classes of IP addresses. We have classes of IP addresses. We have class A, B, C, D, E, and F. So class A, B, C are the licensed IP addresses that are available and used on the internet. So upon the A, B, we talk about that one later. So upon the A, B, and C, these addresses are actually available and it is used on the internet. Okay, so we call this one as well as a public. So those addresses that we use on the internet, we call them as a public. Do you have another one there? So to preserve it, so we are going to preserve this classes of IP address. In order to preserve this, so I forgot something here. If you say 2 to the power 32, do you know the number of IP addresses that we are going to have? If you raise 2 to the power of these binary digits, alright, you are going to get 4.2 billion IP addresses. Okay, I don't think it will be enough for the machines or for the system that it's actually on the global right now, or the globe right now. So in order to preserve or in order to convert these IPs A, B, C, and D, we use what is called, or an address was introduced out of these classes, which is called the private. So to preserve these public addresses, a company can instead use what is called the private IP addresses, okay, for the device on their own private network. So let's assume I have my company here. I can actually use the private IP addresses to do the communications of computers, or to do communications in my local networks. Let me use that term, in my local network. So in order to preserve this, that's when private IP addresses actually came in. So we have public and private IP addresses. All right. So how can we convert a binary into digits, a binary into decimal value, or decimal value into binary? So we said that each octet, we have 4 groups, and those groups, each of them is called an octet. So each octet contain 8 different binary numbers. So if I run using from 0, 2 to the power 0, 2 to the power 1, it will raise to 2 to the power 7. And if we add all these values, it's supposed to give us about 255. Alright, so how can we convert this 115 to binary? So let's assume we have actually learned this when we were in the high school, learn about the binary, converting binary into decimal, or decimal into binary. So we rather converting this decimal value, which is 115, to binary. So we draw this chart here and then try to convert it. So I'm converting this 128, then I'm going to add 16. So 128, if I try to add 16, so it's going to give me 4 plus 1 to 4, so 144. All right, if I try to add a 64 to exceed this number, so I have to try to pick another number. All right, which is 32. It gives me, it's not up to 155, so I have to search for, let's assume, okay, so sorry, so 128, let's use 32 and see how it's going to be. So this part is going to be 0, this part is going to be 60, so this means that it exceeds this value, right? So we are going to use a 16, so we got 144. That is what we got when we add this value and this value. It is still not up to 155, so let's pick 8 and add 8, so plus 8. So 8 plus 4 is going to give us 12. Alright, so remember 1, 5, 1. So 155, it means that 3 more to go. So this one is gone as well. So the 3 more is going to be this one and this one. So we add the 3 to 2, going to 144, 154 plus 1 is going to be 155. So this is how we can convert binary, or sorry, a decimal value into binary digits. So this is how you read it. So it's going to be 100110111. So this is what we have here, 100110111. So try your hands to convert this binary or these decimal values into binary. So let's see how we can actually convert these decimal values into binary. So if we're trying to convert this 254, this is what it's going to be. If you add the first 7 or binary numbers, it's going to be 254. All right, so it's left with this one. So it's left with this one. It's going to be the 255. So what do you think will be the binary value for 8? The decimal value 8. So it's going to be 8. So you have just an 8 value here. So it's going to be 0000100. So let's look at this, 0000100. Okay. So what will be the 255? Is going to turn on all the bits. So that's what it's going to be. What about 10? It's going to be this one and then this one. So it's going to be 100001010. Right. So this is what we have here as well. So I know that you have gotten the gist of how to convert binary, or sorry, a decimal value into binary, or binary into decimal value. All right. So we can reverse this one as well to look at how we can actually convert it into decimal value. Alright, so these are the examples of IP version 4. We have actually seen one with 192.168.1.20. So these are our examples of IP version 4. You see 10. So we say that we have 4 different groups, or 4 octets, and each octet will range from 0 up to 255. Okay, so it means that an octet can start from 0 to 55. So we have a 10 here. All these are our examples of IP addresses. Okay, so we can do the conversion as well, as we have actually made it. So let's look at the classes that we were talking about. We saw the classes when we were explaining some terminologies or some definitions that we are supposed to know about IP version 4 addressing. So we came across about classes, A, B, C classes of addresses. So let's look at what they actually are. So we have class A, the B, the C, the D, and then the E. So let's look at the range. We normally tell see it as what is called a leading bit. All right, so in each octet, so we are hammering on the first octet. So on each octet, it's 8 bit, 8 binary digits are actually there. So we are going to pick the first binary, oh sorry, the first. Okay, so if you see this one is, we make this one as a binary 0, it means that, so when we come here, it means that we are making here starting from 0 at, so because this value has been 10 as a 0, so here is going to be 0 up to 127. All right, the next one we are going to turn on the next one, so it's going to be 128. It's going to be ranging from 128 up to this side, so it's going to be 191, and then the C will start from 192. If we calculate, we are going to get the same value up to 223. The fourth, so it means that 4 octets, or sorry, 4 binary values, and the first octet has been turned on, and then the last one, the first 4 binary digits in the first octet have been turned on. So this is the leading bit that is leading us to the classes of the RP addresses. Note that when it comes to class D, this is actually reserved. It is not reserved though, but it's used for a multicasting address. All right, and the E is actually reserved for special purposes. So we use the A, B, and C when it comes to connecting to devices. Okay, so if you see any address ranging from 0 up to 127, that gives us the class is class A. If you see any addresses ranging from 128 to 191, that's identified as the class is class B. If you see any address ranging from 192 up to 223, that tells us that the address is in class C. So upon the addresses that we have here on a previous slide, you see that the first octet starting from 10, which actually tells us that the class is class A, because class A starts from 0 up to 200 and what? Sorry, up to 127. 172, we are based on the first octet. So 172, which class will it fall? 172 is going to fall in class B because it falls within the range of 128 up to 191. So class C, let's look here, 190, that actually falls here. Yep, so it's also in class B address. Then what about class, this one, number 4, which is definitely class A. And let's look at the 222 here. Let's see which class will it actually fall. The 222 is going to fall under class C. So it means that this address, particular address, is in what? Class C. Let me wrap the screen. Head of a subnetting. So this is a network bit. So you have heard of a subnetting. When you talk about subnetting, like take like a whole pizza and that pizza is divided into pieces. That is the subnetting of the pizza. Okay. So in the world of addresses, or in the world of network, that is what we actually mean by subnetting. So a whole address, like 192.168.100. whatever may be, can be subnet into what? A different network. Okay, a whole piece of pizza being cut into pieces, different sizes or different pieces. Let me assume that. So if you're talking about a subnet, so each class of the address come along what is called default subnet mask. So the class A takes a default of which the largest bit. We learned that we have the largest bits of which is 25555. Sorry, is 111, of which all the bits in the first octet are 10 word on. So 255.0.0.0. Okay, that is the network bits for the class A, and then the remaining bits, which is turned on. So the first octet bit is turned on, then the remaining 3 octet bits is turned off. So the remaining bit is actually referring to what is called as a host bit. So this is the host bit. So this is the network bit. So when it comes to class B, two of the octets are being taken, of which all these two octets are being turned on. Other bits within these two octets are turned on, and then the remaining bit, of which we call the host bit, is turned off. So 16, 16. So how many network bits do we have here under the C? So we have 24 bits, of which the 3 bits, sorry, the 3 octets. The first 3 octets have been turned on, and then the last octet has been turned off, of which it is the host bit. So if you see an address like this, I'll give you an example of how this actually works. You assign an IP address to machines. Okay, yes, okay. So let's come to the IP addresses. I talked about public and then private IP addresses. Okay. So in each classes of these three, the 3 classes that we have, the first 3 classes, the A, B, C, we have certain addresses that were being taken out or reserved for particular purposes, and that address that we have here, we call it a private. Not all reserved addresses are called private, because we have certain reserved addresses that are meant for certain purpose or certain functions. So the class A, we picked that based on the octet that we have. So we pick the first octet. So we pick the first octet, of which was 10. So if you are trying to say which class of address is the class A, and if you see any address that ranges from 10, it means that the address is class A, and 2, the address is private address. It can be used in companies, all right, but we can't use this address when it comes to the public networks. We can't use it, or the public addresses, we can't use it, all right. So you can use these addresses within your domain or your local networks that you are actually setting up. And we have the 8/8, that the side the value that we have, the /8 represent the first bit is being turned on. That is what it means. Okay, so up to 255, 255, 255. In the class B, they took what is called 172.16. So if you see any address that is within this range or in this format, it should tell you that the address is in class B. Based on the first octet, it is a class B address, and 2 is a private because of the 16 of which is being taken when it comes to the second octet. If you see any address like 172.100, 172.0, 172.50, that makes that address public. It is not private. If you look up to the range, that's what actually tells you whether the IP address is public or private. And when it comes to class C, an address 2 was being taken. So 192, if you see address 192.168, that tells you that address is also private address. So based on our lab session that we are going to have, we are going to use a class C so that you be familiarize yourself with. And if you think that you want to change it when you're also making your own personal labs, you can change it to any of these addresses. It will also work for you, right? So let's look at this reserved IP address that we actually have. If you see any of these addresses, they are reserved for a specific purpose. So if you see any address like 255, 255, 255, 255, let's look at the functionality. It is used for the broadcast message by the TCP/IP processing. So we normally call this one as a broadcast address. Okay, it is used by the machines to broadcast TCP messages to all networks or to all computers or all nodes on a particular domain on a particular network. We know that the IP address starts from 0 up to 255, but somebody might say that why is it the 0 is not being used? Because it's currently not assigned. We can't assign the 0000 as an address to a machine or whatever that may be. But the first octet is supposed to start from 1, whereby we need to know that we can assign this value 1 to devices or to nodes that are connected to a network. And if you see any address that is 127, so on the class A we saw that from 0 up to 127, right? So this particular 127, the whole 127 is reserved for a specific purpose. So if you see any address that is 127.0.0, let's look at what is the function. It's used for research or indicate your own computer, in which in case it is called as a loopback address. It is actually used to tell the TCP/IP connection on your machines, or normally we call it as a local host. It doesn't matter whether you're connected to the internet network or not. Alright, so let me illustrate this for you. Let me illustrate this for you. Let me say open the Windows command prompt, and then I want to ping 127.0.0.1. It doesn't matter what I'm connected to it, because this is a loopback address or the local host address that is used to test for the TCP/IP connection. So you can see that it works. It's not necessarily mean that you have to type this. It can actually change the values. Okay, so let's say I can make this one 200 or 234.0.15. It will actually work because it falls within the range. And we can even see that these addresses from 125.255.255, that is the remaining 10 octets. Okay, and we can actually ping what is called localhost. So let me type this localhost here. So my IP version 6 is on, but if I don't want the IP version 6, I'm using the version 4, so I type -4, and let's see, you can see that it's giving me the same address that I typed earlier on. Alright, so let's get back to our slide. So if you see any address, it's called as a loopback or localhost address. Alright, so let's look at the last one. The last one is, if you see any address that is starting from 169.254, this address is indicating what is called the AP, how do you pronounce it, like APIPA, or the automatic private IP addressing. Okay, this kind of address is actually assigned to desktop or host machines when a computer is trying to request for IP address for a DNS of which there is no availability of that particular DNS server on the system or on the network. This is what the machine is going to assign to it. When this is set to automatic, it's going to get the IP address. So let me illustrate this to you and see how this is actually work. So I have a cable connected to a switch on my lab right now. So I just set up this IP addresses 10.1.2.3, alright, using the class C, using this subnet mask. So let me illustrate here to see or to show you how. So you can see that there's a cable connected. So I'll come here, then I'll come to Ethernet. So you can see this address is here 10.1.2.3.4. If I turn this one to a 10 IP address automatically, let's see what will happen. Are we still going to get that 10.1.2.3? No, we are not going to get, because we haven't set any IP address. It's an Ethernet adapter, so we are working down the Ethernet adapter. That's the IP address that we got. So let me use the arrow key to arrow up and see. Now you can see that the IP address has been changed to 169.254.20.220.2. So you can see that it is on our automatic configuration IPv4 addressing. So this is actually a sign when the system is looking for an address uh, on a particular server, and there was not like that server being available. So this is the address that they're going to get. Okay. So it is used to create the automatic private IP address, and when the computer configured for DHCP first connect to a network and is unable to lease an IP from a DHCP server. Okay. So if you see any address that is in this form or in this range, it's actually reserved for a particular purpose. Alright, so I think this is all about IP version for addressing. This was supposed to be part of the day one uh, session. Okay, so if you like this, or if there's anything you want to add up to what I said, you can leave your a comment in the comment section, and make sure you subscribe to my channel. This is a Tech by channel. Subscribe for more videos on Windows Server operating system and networking. All right, thank you.